Hello, we're group number 2 and this is our Blender project. After exporting our model from CAD and finishing the mesh, we made the following assumptions to start the simulation. A constant density for honey and water, RANS, K epsilon turbulence, which is a model that helps the RANS for the equation solution, cell quality remediation that makes a better mesh quality, segregated flow which solves the equation one by one, and two-layer all white plus wall treatment, which are areas near the wall are corrected. For part number 2, these were the assumptions taken into account. The following chart shows the results obtained for water during the simulation, where the Reynolds number and RPM were established and the torque was given by the simulation. And with this, we obtained the other values using the following equations. The graph represents the powers number in terms of Reynolds, and the equation beneath means the Blender behavior. Making a comparison with the literature, the results are very similar.
The assumptions considered for the part 3 are implicit and steady, that allows to define the segregated flow, Euler and multiphase to specify the multiphase models, volume of fluid to simulate immiscible fluids, multiphase interaction, K omega turbulence, and SST K omega. Regarding the two graphics of volume fraction for liquid, we can see the orange parts which represents gas bubbles between the liquid phase. Also, it is evident gas-liquid interface, which is a mix of green, yellow, and blue colors. These results can be explained for the big blades that the Blender has. It is supposed that blades oversee decreasing the vortex, and because of huge blades, it only represents a turbulent flow without vortex we needed. For the velocity profile, it is evident how the velocity decreases as it gets closer to the walls, reaching a velocity equal to 0 at the Blender jar boundaries. Observing the velocity profile of the blades, we can see that the maximum value of velocity is 2.2 meters per second at the tip of the blades, which is decreasing at the vicinity of the blade center. Also, analyzing the white blast, the blades are uniformly blue, which means that the fluid is governed by the viscous effect as regards of negligent inertial forces. The pressure profile was expected because it reflects the reference pressure at the top of the blender and how the values of the pressure increase according to the increment of the liquid.